so let's do problem 380. This time we have to implement these three functions. The first two methods are fairly straightforward. We have to insert the value if it's not present and then return true, false otherwise, remove does the opposite. This GetRandom method returns a random element from the current set we have. And how do we achieve this? There's a method called random, rand, and we can just say new random. And then if you just do rand.nextInt, and then if you put the number, for example, you put 50, you do get number 0 to 49. So if you put the size of an array here, or size of the set, it's going to get any of the random index, and then we can just say return, it depends on what we do, but if it was an array, we can just say array and then whatever number we got from here, from this operation. If we put in here, it's going to return the random number. But the thing is, each element must have the same probability of being returned. In other words, if the number was 1, 2, 3, and 4, it's perfectly fine. They all have equal probability of being returned. But if there's one extra number, this one will have a higher chance of being returned. So in other words, we shouldn't allow any duplicates in our final set. And another thing to watch out for is it has to have a constant time complexity. All of them has to be over 1. How do we achieve that? That's also to keep in mind. And the another thing is we do not know the size of the final set we are going to have. So by definition, array, when we declare it, we declare with the fixed size, so it cannot be changed. Since we do not know the final size, it has to be dynamically allocated. That's why we are going to use array list. Right? So suppose we have 1, 2, 3, and 4, and 5. Okay. And if the remove function was, okay, remove 2. So because there's a method called remove 2, if you just do that, it does not really satisfy this constant time complexity requirements, because what's going to happen is we are going to remove this 2, and then we have to shift all the numbers to the left. That's why it has a time complexity of O of n, so we can't do that. And another issue is because there will be like multiple operations of insert and remove, we do not know the location of this index. Okay, but why do we need to know the location of this index? The reason is this remove has, as I said, has a time complexity of O of n, but it has time complexity of O of 1 if we remove the last index. That's why we, if we know the index of the number we want to remove, we can just swap around and then remove the last index. But there should be something that keeps the record of the indices of the numbers we have in our set. And that's why we are going to use hashmap. So we are going to use hashmap and ArrayList as a combination. So hashmap is nothing but a key value pair. And what will each of them contain? This key will actually contain the actual value. So in our array list, we have 1, 2, 3, and 4. This key will contain the actual value, and then this value will contain the indices of the following numbers, 0, 1, 2, and 3. So how do we do it? Suppose we want to remove this 2. What we are going to do is we are going to get the index from the hash map, put the last number into this number, and then update this 4 index with the correct index, remove the last index, remove this number. So there are a couple of steps involved, so let's just write them down step by step. So get the index, so that should be from the hash map, right? So from the hash map, we are going to get the index of the value we want to remove. Next step, what are we going to do? We are going to update well, it kind of makes sense to update the array list first. Array list, we're going to update, well, move the last element to the index. So basically move this 4 into this index, and then again update the 4 with the correct index. With the index, and then next step, we are going to remove the value. So basically we are going to remove this 2 here, and then remove the last value. Okay, let's see if this one works. Step by step, get the corresponding index, which is 1, and then in array list, move the last element to that index, move 4 to that index, so this will become 4, and then update the last element with the index. So update this one with the index, which will be 1, remove the value, remove this value completely, and then remove the last index. Good, that's our remove method done. We do know what to do for the GetRandom method. Insert method is also fairly straightforward. Put the value into the hash map, and then put the value into the array list. So there are only 2 operations. For this one, we need to use hash map, map list, and array list, and then as well as random. So we have to definitely import java.util. And then we need to declare the 3 methods, 3 variables, which will be private. It will be map of integer. I'm gonna call it nummap equals new hash map, and then we need private list integer num list equals new array list, and then we also need private random rand equals new random random. Okay, so insert. Let's start with the easy one. If the value is not present, or if the num map that contains key var, if there is a value in it, what do? We have to return false. Right, remove the ultimate if it's present. Remove insert if it's not present. So if it contains it, we'll return false. Likewise, if nummap that contains the var, if it does not contain the var, there's nothing to remove, so we have to return false. Otherwise, we have to put the values in. So we are gonna put the nummap.put. Where are we gonna put it? Has to be var, and then what's the index? Suppose the array list is empty, hashmap will also be empty, so we do know that the number of the value we're going to put it will be 0, which will actually match with the size of an array list. So num list dot size, and then we have to put num list dot add the value to the list. Alright, the remove, we have to do these 5 steps. So because we're going to use index a couple of times, I'm going to do step 1 into storing the value into the index, which will be nummap get var. By the way, contains key method is of 1, this get is also of 1, everything will be of 1, and move the last element to the second step, num list dot set. We are setting the so the operation will be index and the value. So index and the value the last value will be num_list.get and num_list.size -1. That's the last element. Moving to the correct index, and then we have to update the last hash map nummap.put. So we're putting the number. So we're putting this 4. So the 4 should be the last element. We're putting the last element again with the correct index. And then we have to remove the val from the hash map nummap.remove val. Again, we're removing the last element. Num_list.size -1, the last element. Alright, and then we have to return true. Again, we have to return true for the above one because it's a boolean. For GetRandom, because we had rand here, rand object, rand int random number equals rand.next int. What's the size? num_list.size. Return num_list.get random number. Alright, okay, let's run the test. Okay, it should be contains key. Alright, it's accepted. Let's submit. Okay, it has a speed of 92.34%. The better one isn't 21 milliseconds. It's just this one literally depends on the internet speed, so that's the best we can do. Right, so that's it.